I built an AI in Minecraft, and this is how. Minecraft. Most people already know what Minecraft is. It's a survival sandbox where you gather resources, craft, and beat the end dragon. I want an AI not to beat Minecraft, but to survive and evolve with Minecraft as the environment. So I took inspiration from the Bibbits. The Bibbits is an evolution ecosystem simulator with neural networks that work by taking input numbers, applying math through nodes, and outputting an answer, in which you can tweak the node weights to change the answer. Also, body mutations, such as size, muscle composition, and even things like mouth size or stomach capacity. I wanted to take these concepts and run them in Minecraft. As some of you may have already figured out, it will be extremely resource intensive to run that many AIs or Minecraft instances on my PC. So I took inspiration from another YouTuber, Geosquare, and their video on the quest for the tallest cactus. They used distributed computing to calculate the tallest spawning cactus based on the world seed. I could use that concept of distributed computing in my AI by running one AI per PC and connecting through Minecraft's multiplayer. I could theoretically have thousands of AI interacting, reproducing, and dying, all in the same Minecraft world. So now that I have an idea, it's time to make it a reality. Let me start this off with the fact that I am not a coder. To build this, I slowly vibe coded it with ChatGPT and DeepSeek. But after a full year of work, I have a rough working prototype. Now, version 0.1.0 was me figuring out the basics of running a deep queue network in Minecraft. A deep queue network is like a neural network, but it's deep. You can use an experience replay buffer and rewards or punishments to train the DQ in. To get it to run in Minecraft, I needed to capture the Minecraft screen. I used grayscale for that. Simulate actions. Reward and punish the DQ in. I used health and hunger. And mutate the offspring. For that, I have a 50% chance to tweak the weights of an offspring. In version 0.2.0, I realized that I cannot make rules in-depth enough for Minecraft. So I decided to have a second AI do that for me. I set it up with two DQ ins, one receiving the visual input and simulating a key press, the other receiving the next visual input and giving a reward or punishment. Now the reward logic can change and mutate over time. I also added new mutation logic, like add or subtract a neuron or layer. Also adjust weights and change layer function. In version 0.3.0, I added audio as an input, and a recursive loop where two of the DQN's outputs act as two of the other DQN's inputs. My hope is that this will allow the AI to develop more complex behavior. This also expanded the DQN, and I had to update everything the new design broke, except for add or subtract neuron or layer. That part still doesn't work at the prototype stage and is still full of bugs that I need to work out. Version 0.3.6 is the current version with the working server client AI distribution. The diagram here shows how the AI ecosystem works. Each AI plays in Minecraft, and as it lives, its score goes up 1 each minute. And if it's bigger than the egg score being the number of AI offspring waiting in the server queue for a computer plus 1, it gets to reproduce. As AI die, the eggs in the queue get sent to be run. Over time, this should cause the natural selection to improve time alive. Now let's get to the actual run. This is my second run so far. To test it, I ran it with one client for 4 days in a super flat world, with command blocks that kill the player if the player stands still for too long. With this environment, we should see evolution push towards movement. I then generated an AI with random weights and let it run. During the run, I noticed these guys, wandering traders. They would spawn in every once in a while and bump the AI, resetting the kill logic and causing a spike in the population in the egg queue, then a drop in the population. Eventually both ended with an AI population that walked, proving that it is working. Here's the family tree, starting with a random AI, and slowly, over 186 generations, the AI mutated until it could survive longer. As you can see, there are points where the population grows and decreases. Those are the times when the wandering trader spawns. At one point, the population dropped to 1 because my server PC egg storage filled up. Then, nearing the end, you can see that the population starts to grow as the population's ability to survive increases. Here's a plot graph of the time alive per generation. You can see that by the end, the time alive for the population has improved. The plan for the future is to complete 0.4.0 and start a continual run for a month where I stream the process. At that point, I will also be releasing a more technical explanation and a way for people to download and run it for yourselves. Thank you all for watching. Shout out to Bibbits, CodeBullet, and GeoSquare for being a big inspiration to this project. Links in the description to their channels. And if you have any questions, please leave them in the comment section and don't forget to subscribe.